Okay, it'd be great if you can start with telling us a little bit about this Pipebots for Rising Mains Phase 1 and 2 project. So how it came about, the people involved, and I suppose the objectives to start with.
Yeah, thanks for talking to me. Yeah, and let's start with Pipebots. This originally was kind of like a university sort of piece of research with Sheffield University and other universities that looking at how robots could kind of help within pipelines to sort of do sensing and things like that. And it was kind of how can they communicate, how can they move, and the water industry were collaborating and steering on what that could look like. So this project is just one of a few things that are spinning off from that fundamental research that's university based. So this is Pipebots for rising mains. So rising mains, normally our network is gravity. So it's sort of like, comes out of your house and kind of like goes downhill, but eventually that gets a bit too deep. So we have to pump that sort of back up, and that's the rising main section. It's only about sort of 3% of our network within Thames, but it does cause us most of our pollutions on that side. So it is sort of a critical asset for us in terms of pollution. Pollution is a sort of industry-wide issue, and so we're all kind of collaboratively working together to look at this to improve our condition assessment and turn this issue into being what's currently a bit of a reactive sort of reaction to when the pipes burst, to becoming a bit more structured and planning ahead and getting information to know before they actually burst and put our investment in the right place. So that's why we're kind of doing this for the industry. And the aim of the actual project is to test the sort of use of those robots within a rising main so that we can identify and address the deterioration early and actually prevent those bursts from happening. So, we could easily use sort of person-controlled units, sort of like in our gravity sewers, but not so easy in the rising main environment. And it's difficult. We don't know kind of what that environment is. We've often had to turn off the pumps and actually sort of turn off the pumps and sort of like actually do the intervention then. And that takes quite a lot of work and effort in terms of turning the pumps off. So you're not taking the sewage away. So you've only got a set amount of time to work with and covering that with tankers. It's all sort of disruption in that local area and on managing those flows. So what we'd like to do is actually do this whilst it's still operational. So you're moving that cost from the actual operation that at the moment makes it not cost effective into the area of sort of just being the risk budget and just there in case you need it, and hopefully you won't. And then we might be able to do these surveys and sort of then preempt kind of like and understand our assets a bit better to know before they burst. So we hope that this project is going to develop as a technology that can cost effectively sort of survey our sewers and survey our rising mains. And from the inside, I think that's the key thing, not from the outside where you've got to dig down to them, which again is an additional cost, and survey them from the inside while still in operation, covering as much as we can rather than just a spot sample, so that we can understand and plan and replace a lot better, preventing sort of like a burst occurring. Now, we teamed up with Wessex because we were talking to them about, in particular, sort of iron assets, and we've done quite a lot of sort of research previously, understanding our clean water assets on that and transferring this to sort of waste and our rising mains. So we were talking to Welsh and Wessex already, and we knew about the Sheffield development on the new sort of sensor technology through the Pipebots research. So we'd already teamed up together, sort of had this concept for the Ofwat Innovation Fund, and then we got Synthetech on board through a sort of contractor selection process, and went in, put a submission in just to do a research and feasibility stage at the start. That was back in Water Breakthrough 2 for about 230k. And so we did that and worked together, and we got it to a stage where I think we're getting a lot more confident that we sort of knew what we would like from that technology. And so then we've got to phase 2. So we've put together sort of a proposal, went back to the fund again, in WBC4, and that was for about 1.7 million. And yeah, we've been successful. So we're about to start that now, and it's really exciting.
Okay, and in simple terms, and you can perhaps sort of flesh it out in rather more detail, you're using a combination of robots and sensors to deploy them, as you say, inside the rising sewer mains to basically assess their condition and, as you say, to preempt potential problems. So that sounds simple, but what's in practical terms, what does that, what are the logistics involved to actually achieve that?
Yeah, sure. So like I say, we're at the start of phase two. So I'll talk mainly about sort of the process that we went through on phase one and get on to phase two afterwards. So initially we had like a desktop study. So we shared the information on what our assets are like, what the issues are, what our needs and what the practicalities are as well. So for a start, it was kind of, let's put it on a cable that can be pulled back. We don't want a free swimming robot that we're going to lose in our rising main. So, that bit of kind of like risk was okay. This is where we're starting. So, we got those on the table first, sort of as a collective. And then we reviewed the market for sort of what sensor technologies are already out there, and what robotic methods and that we can use for sort of going through the actual pipeline. Then we did some initial site investigations and scoping. So Synthetech came and had a look at some of our sort of rising main archive, having a look at failures, so how they fail, how they deteriorate, to get that feeling. And we passed some of those samples up to Sheffield, so that they could sort of do some first initial analysis on them, and I'll tell you about that in a second. And then we also did some field visits with both Wessex and Welsh, and one site had dampening of pumps and one of them didn't, so it had the two extremes of those scenarios. And we did some external pipe analysis on that, so sort of put some sensors on to sort of see how much the pipe sort of actually moved, what noises we could hear. They were quite different and quite what we didn't expect. So it was really good insight and a good use of that research and feasibility sort of study to do that. We then took that sort of information and the university did some initial modelling to sort of like look to see what they expected to see and then what we did actually see. And then some lab testing as well. And that helped us sort of specify the sensors that we would need. So the university would say, well, I need this, and then Synthetech would then have to sort of like purchase the right ones and then try and assemble them and get them on the equipment right. And so that took a real sort of collaborative effort between those two to actually make that work and happen. And then we had to sort of like actually prove it through sort of the rig tests. So, on that first feasibility stage, it was basic principles, but it was kind of like, well, we've provided you a sample. It's a real sample, not a machined one, but, it's got through wall holes in it. So, can we see that or not? And luckily we did. And then as well, we looked at sort of really end to end. When we come to actually use this in the field, what do we expect it to look like? And so looking at, have we covered everything? What will we expect to experience? And so what do we need to check out as part of our next stage? And that's where we are now going into phase two, is we've got all that information together. We're re-evaluating that. We've learned quite a lot on that stage, and actually things have changed a little bit. We'll go from here, and hopefully at the end of this sort of phase two, which will take through sort of a lot more extensive testing, rigorous testing, to sort of test everything out as much as we can on the sort of the lab and the rig and through the modelling, rather before we kind of get out into the field, which is where we want to get to at the end of this stage. Yeah.
I'm just wondering, in terms of the inspection process and what you're finding, I mean, you're hoping to, or presumably not hoping, but I mean, are you looking to find potential problems that are easily identifiable? Are you looking to build up, if you like, a database so that eventually it can automatically sort of identify from a library? It's machine learning, AI, etc. What's the, I suppose, what's the plan there in terms of how autonomous the solution might become, I suppose?
Yeah, so our initial thoughts is that we need to know, so we're targeting iron assets because they're our biggest stock that we have kind of like across the industry. And what we'd like to do is do this assessment sort of as long as we can and sort of circumferentially as much as we can. But at the moment, you just take a single spot sample and assume it's the same all the way along, where we know it isn't, because it deteriorates from the inside through sort of pockets of gases, but also from the outside, depending on what the soil is around it as well. So we know there's this high variability. So the more that we can get in doing that from the inside is obviously a lot easier than the outside. And so what we're looking for is the wall thickness. So that we can, if we can see that variability in the wall thickness and its corrosion over time, then we can start to say, okay, this one's at a higher risk than the other one. But yeah, it's a good question about how we're actually going to handle that data afterwards, because it is, at the moment, we don't have that library of data. But once you start collecting it, and I think the first use will be looking at it for engineering terms to say, what can I look at this single asset? Can I, safely sort of like only invest in half of it? And go and spend my money elsewhere, and make it go further, or do I need to replace the whole lot because it's all at risk, and we make sort of data driven sort of choices rather than sort of risk-based assessments. So but we need to start collecting it, and at the moment the barrier is the cost. Because you're either just taking small spot samples, you're still having to dig down, or you're having to create new access points, which is expensive itself. So this tries to get over those barriers to make it more cost effective, so that we can start collecting that data and turn it into being more proactive to prevent the bursts.
Okay, and in terms of, I think as we've been talking, you've outlined some of them, but in terms of the key learnings and the insights, with anything in particular, and I guess I guess the overall benefit is you're looking to significantly sort of improve asset management eventually. But just your thoughts as to what you've learned as you've been going along in terms of what's been useful and whether actual or the potential benefits you can see of the work you've done.
Sure. So I think we see quite a bit of potential in that this is our need at the minute, and it's quite transferable to other needs as well. I mentioned clean water assets. We could transfer it to that in future, but it's similar. Gas in the oil industry, do use a bit of this technique, but our applications are quite different. So it's trying to bring that application into the water industry. But with the sensor technology, there's no reason why that couldn't transfer back potentially either. And so, I think there's a lot of scalability and potential out there if we can actually do this demonstration and get it to work. But also, it's really the journey of this as well, and just sort of taking a concept sort of like from the university and actually communicating and working together collaboratively to sort of understand what the issues are. And I think that's why the Ofwat Fund's really good. It's not just about us learning as a team and trying to get this technology in for us to use, or it's that we want to share what this issue is, so that other suppliers can potentially sort of understand where we're coming from as the water industry and help us overcome those problems with their own technologies. So, we want to encourage the sort of like market, and doing these kind of interviews, hopefully will, bring those suppliers to kind of like come and talk to us about, how we can, potentially use other things to do a similar thing on either these assets or others.
Yeah. I assume as well, it hasn't all been, shall we say, plain sailing. So have you come across any potential actual challenges or gaps in terms of what's still in the I don't know whether deploy. I presume deploying sensors sort of down deep underground, etc. Perhaps not that easy. You mentioned the risk management. I think that's potentially a nightmare in any scenario, but this one maybe more. So just anything that you've sort of still got to get to grips with, or at least was a challenge but you've overcome it.
Yeah, so I think in the initial feasibility study, we sort of demonstrated that we could get in and out of the main. And I think we are, looking at the whole thing and looking at the costs. I think we would like to move to something that can get through more existing assets because it makes it more viable as a product. But there aren't that many either, so it's kind of something that's an easy fitting to do sort of employ. But also, you know, it's quite variable. The materials are so different. You know, we're focusing on metallic because it's the largest, but you know, there's potentially lots of others like GRP, PVC, and asbestos cement as well. You know, so there's other. If we can get in and out, then you can just apply perhaps different technology to sort of do assessment on those instead. But also, you know, we need to kind of like actually pull together kind of how we're going to do those surveys on the pipelines, and one with the actual robot itself actually. So getting it in and out was probably looking at sort of like a smaller entry point than previously. But you know, it will make it much more viable to do that. Now, at the moment, we've got it on a halo, and we've known from the start that it's likely to get ragged from the wet wipes. It's going to encounter silt and things like that in this environment. It's quite harsh. So we're putting the sensors on this halo so that we can get as close to the pipe edge as possible. But the issue is we know from the start we don't want to do that, because as well as the access issue, it's also that, you know, we're going to be encountering all these things inside. So we want to bring it into sort of like the body of the unit as much as we can. But, you know, we're going to have to start from there, but knowing from the start that's what we want to change. So we have to give the sensors the best kind of like a ability to succeed as we can, but then knowing that we're going to have to compromise on that later, and kind of like what will that compromise be in terms of the actual sensors, or, you know, can we actually do better? There's also issues like we hadn't realised that we hope to use actually the sound of the pumping stations. So that's how we envisaged when we first started. But of course, that exploratory piece of work sort of showed that you know, it's so variable that we can't rely on that. So we're having to put a sound generator on board, and you know, and how do we make that sound as we go along? So that's changed, but that's not too much of a problem. But then we actually noticed that with the modelling and stuff, actually the unit itself, the tractor unit we came up with at the start, was actually causing its own vibrations and influencing the fluid as it went through as well. So we have to account for that too. So it's quite complex, and there's been these sort of challenges that we didn't expect. I mean, even getting kind of the sensors and actually plumbed in like the sort of like right, looking in the right direction. Like I said, took quite a lot of communication between sort of like the parties to kind of get that right. Didn't happen first time, and we had to try a few times.
Yeah, and in terms of, so you say you're moving on to phase 2, and obviously early days, but what's the time frame, and also what would you hope, you know, to have the end result to be? Where would you hope to be once you've carried out phase 2 in terms of getting nearer to something that's, you know, commercially viable, if you like, for yourselves and others?
Yeah, sure. So we started in September, and you know, we've sort of stood back, kind of like did a re-profile of it. I did a bit of a workshop to start with as well, and we've kicked off really steadily, and you know, making really good progress so far. Like I say, there's been quite a lot of a rethink, but you know, I think that feasibility stage has really helped us to sort of ground this a lot better. And so we're aiming for June 26th to finish this technology development. And actually that will take us through to actually doing several tests on a more complex rig, and like I explained, there's going to be a lot more sort of vigorous and intensive testing, and trying to do as much offline as we can. But we do hope to actually do a final field trial out on site at the end, just to demonstrate that we can actually do this and what results we get back from that, and get that verified. So You know, that's where we hope to be next June, and hopefully we'll make that. We've already chosen, well, we've already found a site that we could potentially use, so I'm quite pleased with that. We'll probably have a few others sort of like in the pocket as well, and see how the spend is going. I think one thing we learned as we went along is the first application we didn't have a risk pot at all. And going into this second phase and having learned from other Ofwat projects as well, and especially with this phase where it's a lot more technically difficult than the feasibility stage, having that security of that risk pot there if I need it is really, really useful.
Okay, and maybe just in finishing, it is probably not so easy, but in terms of the potential impact of, you know, if the project, assuming you know success is achieved, I mean, I'm sure it's difficult to put a monetary value, but if you are able to much better manage the rising sewer mains, you know, the condition and preempting problems, etc., just how big an impact will that have, you know, positive impact for yourself? I suppose put it the other way, how much of a problem is it at the moment, which you can potentially therefore eliminate?
Yeah, so you know, I've got a couple of figures here that, you know, there's about 15,000 kilometres of rising mains kind of like across England and Wales, and you know, we have about sort of so over 700 bursts a year on those assets. So you know, they're not all iron, they're not all going to be part of this, but that's the ultimate potential of the number of bursts per year that we could prevent. That's just figures from one year, they go up and down, so you know, it's kind of not every year. But you know, they are our highest category kind of like pollution event because they're pumped, and so they're uncontrolled, and unless they're noticed, you know, then you know, we do want to sort of focus on getting our you know, getting our understanding better on those rising main assets so that we can protect ourselves in the future. But yeah, so there's quite a lot to be done there, and you know, I'm hoping that this technology will kind of come to the market sort of like within the next sort of 5 to 10 years. This just does the technology development, and like I say, we want to encourage others too, but you know, I can't make any guarantees obviously, but it is kind of, I hope we can sort of do some demonstrations, you know, this AMP, just to show what potential it has in terms of what data it can show us and how we could change our way of operation, and turn this into a much more improved asset management system, more data driven than it currently is.
That's fantastic. I mean, it's been fascinating to hear you talk about it, and it sounds a, you know, brilliant idea, and it looks like it's headed in the right direction, which is always good. So really appreciate that, and maybe you know, in a year's time or whatever, when coming towards the end, it might be good to catch up and find out where you've got to. But at least for now, really appreciate the time. So thank you very much indeed. Thank you.
Yeah, thank you. Thanks very much.